And maybe to keep you awake in between, I will ask you questions, yeah? So you have to think a little bit. So my talk is about assessing strategic risks in coordination games with FMRI. So this will be obviously a very different task. So I present an experiment, and maybe many of you have never seen actually an experimental paper. That's what I know from my macro colleagues. And on top of it, it's a neuroeconomic paper. So this is getting into the brain, so it's even getting deeper. So for those who have never seen it, it will be complicated. I give you all the information, but due to inattention, maybe from your side and my side also, you might not understand every detail, but you can definitely ask a question immediately when it's about understanding, yeah? Because you really need to understand the experiment, at least, in order to follow then what the results are. So what are we asking? So the key question basically is, what is the difference and similarities between interacting with nature and interacting with other players? So that's a very deep game theoretic and decision-making problem. Yeah, if you could think, well, there should be no difference. I mean, you act against other players, so you have some probability distribution what other players are doing, and you give best response. So the answer could be, well, there should be no difference. And in fact, it depends. It depends what the game we are using, whether there is no, or whether we see high correlation in behavior, or whether we see low correlation in behavior. And on top of it, we can see now in the brain, and we can see when there's no correlation, maybe why there is no correlation. And fortunately, we have game theory. Game theory actually tells us why at the end there might be actually in some games correlation, in other games no correlation. So what game should we use? So we use coordination games. I mean, that's why I could speak to you today. If I had done trust, maybe you would not have invited me. The advantage of coordination games is really that we have to coordinate. So we have to think what others are doing, and we don't have to think of trust and fairness and altruism and all these things. So we can really look only at the strategic behavior of people. So why is this also interesting for macroeconomists? I mean, many things that came up here I will tackle. So first of all, we are talking about risk. Risk is interesting for macroeconomists. Typically, you take some risk parameters and put that in your models. Yeah. So here we see whether actually what kind of risk measures we can use in the game models we are doing. And then what came up again and again was also something about cognitive hierarchies of beliefs. So can we do just best response to our beliefs, or do we have to take into account that the others are also giving best response to us? So that's the beauty contest story. And again, in some games, we can just give best response. We don't have to think what the others are giving best response. I mean, you are immediately in a fixed point. In some games, you are not. Yeah? And what games do I use? I mean, we have talked about coordination games with strategic complements, with complements, strategic complements, and substitutes. So it will be very different whether we are in one or the other situation. Yeah, so this also helps maybe to understand some issues in macroeconomic dynamic processes. What we don't have state variables, and we have macro story. Well, it's about investment. So we have complements, strategic complements, when we all want to invest and we are interested that all others are investing. What is the situation when we have substitutes? That's when I want to enter in the market, but there is not enough space for everybody, so I hope not everybody enters the market. So there is the competition, and this leads us to hierarchy of beliefs also. Okay, that's the introduction. We have, since we are talking of risk, we talk of exogenous given risk, so the probabilities are known, so we are not in an ambiguous situation. And endogenous risk uncertainty is when we play against players, so we do not have objective probabilities if we are not talking of course, equilibrium behavior. Yeah? So our research question basically is, how does the brain resolve individual, so lottery behavior and strategic uncertainty, and how can this explain us a certain type of behavior? So I want to make you wake up. So now you have to wake up because I want to do an experiment with you. So I have 3 different trials. So you have to choose between A and B. If you choose A, you get a fixed payoff. This is known. You see it on the screen. When you choose B, you get either 15 or 0, and we just place 15. But whether you get 15 or not with your B choice depends either on the die. I mean, then it's just luck. It's nature. Yeah, and we show you 2/3 of the time you can be lucky. Or it's the behavior of 9 other players. Yeah? And then we have 2 possibilities. We say, well, we need enough people in the choosing B that our investment will be successful. So we take, for example, 4 out of 10. Well, that seems not so complicated. Yeah, I mean, you have a big crowd and only you need 4. So if there are at least 4, including yourself, then you get 15. So that means this is a game of strategic complements. Strategic substitute is when you should not have more than 4. So that becomes really a quarrel. I mean, how can we solve this coordination problem? And I can tell you in behavioral studies, people solve it. I mean, they basically play the mixed equilibrium that more or less 4 go in and 6 stay out. So that's our games, and now I will play with you 3 of the. So we are in FMRI, so we are in the scanner. We can only take 1 person at a time. We don't want to allow for learning, so we make a lot of choices, 210 actually. We are looking at the brain, so we need a lot of choices because there's a lot of variety in the, between subjects and within subjects. So no information, no learning. We just look at the strategic behavior and when we increase or decrease uncertainty. Yeah, sometimes it's very clear what you do, and sometimes it's not clear. So, well, yeah, that's in the aggregation. Yeah, but we will show you something like this. Of course, they play pure strategies because we don't allow mixed strategies. Yeah. Yes, you will see it now. Look, let's just, here we have the situation. That's exactly the screen, only we don't have A and B placed, yeah? So A, left-hand side means fixed payout of 950, right-hand side means 15, and the roll of, if the roll comes up 1, 2, 3, 4. So you know that. You know exactly in which game you are in. And you know that there are 9 others. I mean, here it doesn't matter. So now choose A or B very quickly. You have 6 seconds. I mean, maybe I give you less. Yeah, so you choose, yeah, you have chosen, and then it's over. Yeah, if you haven't chosen, then you don't get nothing if this was. Now we are in a coordination game with complements. Yeah, we have explained that to the subject. So at least 4. So choose again. Do you want A or B? Right? And of course, we can vary A. Yeah, we can make it lower or higher. So we make it from 1 to 21. Yeah, so if it's 1.5, it's very clear what you do. If it's 9.5, I mean, that's the risk neutral almost, yeah? So when it gets higher, you have to think, well, do I want to risk to lose 11 and get 15? Yeah, so these are all the possibilities. We can also say you need 7 out of 10, so we make it tougher, or 10 out of 10. Or we can even have 2 people only. Yeah, so in macro, you are interested in this question, is it the same to play against 1 person or against a group? And you say that doesn't matter. Yeah, and we can precisely look whether it matters or not. Question?
Yes, Rosemarie. So what's the role of the 6 seconds? You have given all the instructions to...
Yeah, we have given all the instructions beforehand, half an hour or so. Yeah. Yeah, and in FMI, I mean, in most cases, you give fixed amount of time. 6 seconds is enough. Yeah, I mean, you have really gotten a good instruction. So now here's the game with substitutes. Yeah, only 4 can enter. Yeah, so I could play the game if I had more time. So it's 3.5. That's pretty low. You think, well, I enter, but then you think, well, if everybody enters, I lose 3.5. Yeah, so we vary again 3.5, and yeah. So, and we do that randomly. I mean, we every period you get another screen, and it's all mixed. All the different screens are mixed. So sometimes a lottery, then substitutes, complements, etc., etc. Yeah. So that's basically the setup. Now I give you the full design, and I can go fast because I already explained to you everything basically. So we have the lotteries. Here we have 2/3 probability. Then we have the Stackant game. It's written with a U, I think. Yeah. Then here we have k equal to 4 and 10, and then we have the entry game with k, 4, and 10. But we need a lot of observations, yeah? So we vary the sure payoffs from 1 to 15, yeah? So we vary also the probabilities just to get a lot of information, yeah? And we want to assess each person's risk aversion, yeah? So basically you just check where they jump from B to A, yeah? And then this gives us basically the parameter for R. We want also more on like when coordination becomes more and more difficult. If you need 10 out of 10, I can tell you best responses don't go in because you always have one fool who is not in. We have n equal to 10 or 2, and the same in the entry game. Yeah? So more on design, I mean, we have subjects, they see 210 different screens. We have one, of course, only at the time, and people know that there are other people coming, and no feedback. That's the most important. Yeah, there's nothing else in the design you really need to know. Equilibrium is clear. When we have complements, all choose A or all choose B. The mixed equilibrium is highly unstable, highly unintuitive. In an entry game, so the higher the sure payoff, the fewer people, of course, also should go in. And basically, you have a mixed strategy equilibrium. You don't have, I mean, you can say population, you have pure population equilibria. But so this game is very different. So theoretically, it's very different to the complements, and you all know these.
Sorry, I do not understand how you can even think in terms of mixed equilibrium in this experiment.
No, yeah, exactly. You don't. So what you do, and I played that with Aumann, and Bob Aumann spoke aloud in front of me. And so he said 3.5. Of course, I take 3.5 because the others will go on. And then he said, well, maybe I should go in. And then he said, well, maybe I shouldn't go in. And he went out, and he got 3.5. Yeah, so you don't think of mixed equilibria. Yeah, and I mean that's what we want to do. I mean we want to see how people choose these games. I mean you're not sitting down and doing the calculation. You have to solve it in another way. But you are in a circular reasoning, of course. Yeah, and this is exactly the problem. Yeah, when you have substitutes, you have to think what the others are doing, and the other are reacting to what you are doing. I mean, that's all in your head. Yeah, so this comes to my comment to Roger at the beginning. Yeah, so whether we have level 1 or higher order beliefs, that depends, for example, here in this game on the structure of the game. So we are not as unoptimistic, and we can show you. I mean, here we cannot show you how much they go back and forth by the choice, but we can see time. I mean, how long does a person take? And indeed, people are very different from how long they take. Funnily enough, choosing A takes much less time, so they don't go much back and forth. Yeah? But the most important, we can look in the brain, and we know from the beauty contests, which we also played, yeah, that's the game which basically always comes up. You have a parameter times the average player, so you have to hit that. There we see exactly how many reasonings they do. I mean, we can infer from their choices. Then we look in the brain, and we can see what happens to a person with higher level of reasoning, what activity he has. And then, although in another game where we don't know from the choices what players' reasoning level is, we can look in the brain and see, a lot of activity in this area. That's the medial prefrontal cortex. We know this person most likely, I mean, there's a high correlation, has higher level of reasoning. Yeah? Yeah, good. Yeah? So now we do this back and forth. Now I show you quickly, 2-3 minutes, behavior. So when you have lotteries and the probability of winning a high prize is low, then most likely you choose A. Yeah? Most people choose A. Yeah? For 1/2, it's already less likely, and 2/3, there are few people who choose A. Yeah? That's the coordination with the lotteries. Yeah? Here. Now we can look at the coordination game, and it's just the reverse of this. Yeah? The easier it is, the more likely you choose a B, and the more difficult it becomes, you choose B. And in fact, if we look at the behavior of the people in these two situations, it's highly correlated. Yeah? So the correlation coefficients are like 0.4 and higher. Yeah? So we rank everybody according to the risk parameter, and then we check how often they choose a B in the coordination game. When we look at the entry game, yeah, so I show you that on the next slide, basically. Yeah, so we categorize people in risk types and risk-loving types. Yeah, risk-averse and risk-loving type, given the lottery choices. Of course, I mean, it's clear that in the lotteries, that's the per definition, you choose, when you're risk-averse, you choose more A. So how about when you are now entering the coordination game, the stack hunt game? Then again, you are risk-averse, you choose less B than a person who's very risk-loving. Yeah? But when we look at the entry games, whoops, nothing. It disappears. I mean, your risk attitude completely disappears. And that is, you are reasoning about the others. And you might say, well, I'm risk-averse, so I should not go in. But then maybe the others are risk-averse, so I should go in. Yeah? And then you separate. Yeah? You are separated. And so in talking about risk aversion, the problem is that sometimes you get very good correlation, sometimes not, and it's a big puzzle when, why, and when. So here, game theory guides us completely. So when you have higher level of reasoning here, the risk aversion basically doesn't characterize you anymore for entering. So that's basically what I wanted to say about behavior. Maybe just a quick thing for Mike. Yeah, so he was talking of, you choose A and B, yeah, but maybe sometimes you are fuzzy. Like this person in the coordination game with 7 players, yeah, 7 have to go in. I mean, he's pretty certain what to do when the outside option is low, yeah. But when it's in the middle, he switches back and forth, yeah, or here also. Yeah, he switches back and forth. And so you don't have a clear cutoff. The econometric, basically, estimation will be a logic function. Yeah, so this is just for Mike. I mean, Mike probably understands it. Maybe also. Yeah?
I know that people use higher order
What?
looking at the scans.
So we can see it by time, and I will show you.
Time doesn't tell you what people are thinking.
No, I will show you whether, this going back and forth, that's an indication of higher order beliefs, but we see it in the scanner. I will show you in the scanner.
Yeah, I'm sure you're going to see some pictures in the scanner. You have to translate it into English.
Yeah.
Okay, maybe people doing something completely different.
Right. But we know from other studies and theory of mind studies by psychologists and neuroscientists that if you have high activity in the medial prefrontal cortex, this is an indication that you have a model of the mind of others and you're thinking what the others are thinking. If you don't have a model of the mind of others, yeah, then this area will have little activity. Yeah? That's all. Correlation.
There's a particular part of the brain
Yeah.
which tells you how
There are several parts.
other people.
Yes, exactly.
I find it unbelievable.
It's unbelievable, but it's true. So I will not,
So
now.
when I look at a monkey, and I
Oh,
look
the
at what
monkey.
is thinking, that same part of my brain will also be active.
So the problem is,
I think the monkey's smart. I think the monkey's smart. That part of my body, my brain also active.
next, in August, I will talk to Jose Cal. So,
It's not a higher order belief. It's a much more complicated.
no, wait.
Maybe you're thinking other things about other people. How do you know this higher order belief?
So we have to do experiments which indicate with your behavior whether it's higher order of beliefs. Like with a beauty contest, if you choose 33, you don't have much, you have no model of the other person. You think the other person chooses random, yeah, 2/3 of the average. When you choose 22, then this means you have already a model of the mind that the other people are level 1.
You're thinking about other. That's what you told. You did tell me you haven't proved that you have a model of higher order belief about the agents. Maybe you're thinking other things about what other people think.
Yeah, of course, you can, but you see, as an experimenter, we try to find games where behavior separates different orders of beliefs. This you have to,
You have to take face value, right?
no, this is 20 years of work, and we have to, I cannot talk about this now, yeah? So now you have to believe me that somehow we can. Look, have you ever seen Nurik? No. Look, now we come to the brain. I have 4 minutes. And so basically we have...
Depend on the mental activity of your brain.
So basically, I show you now...
Go on, because...
Yeah, we have now two networks, the mentalizing and emotional network. And what I show you is that when we play games, we have to think of other people. Yeah, so this is indicated here that in the medial prefrontal cortex, which through many, many, many experiments shows that this is the theory of mind area. When you do games, then you think of others, and you in fact get, now the mouse, positive activity. When you play lotteries, I mean, that's an indication, yeah, you don't think of others, so you don't have activity there. Yeah, so this is a very clear case in lotteries. You don't need, especially if you don't get any information of others. Okay, now, does it pay? This is an economic story now. Now we show expected payoffs on the x-axis and medial prefrontal cortex activity in some way. So in the entry game, yeah, when thinking gives you different reasoning, then the more you have activity here, the higher is your expected payoff. And we in the beauty contest game, we see that beautifully. Yeah, the more you engage, I mean, basically you get activity here, that is level 2 and higher reasoning, the higher your payoffs. In the coordination game, then the stack hunt game, there is no correlation. I mean, you can think as hard as you want. You can use, you mentalize what the others are doing, but you are not distinguished in your payoffs from the others. Yeah. So now we come to the insula, and I will give you only two important results. So in the insula, now you see in the middle prefrontal cortex, behavior between lottery and games is very different. Yeah, so because mentalizing means you do that in games. However, when we come to the insula, that's fear and motion and all this kind of stuff, then lotteries and stack hunt game is not distinguished. Yeah, so this is very similar. I mean, you get the same excitement. You have the same, your risk attitude helps you to sort of, I mean, sort of gives you the same result. In entry games, that's very different. And now last result. And this is the first result of this kind, when we look at risk-averse people, when we separate risk-averse and risk-loving people, then we suddenly see, aha, they have a very different activity in the insula. And that's the same for coordination games, stack hunt games, and lotteries. Yeah? So we see high correlation in behavior, and we see high correlation between in the insula. That's not the case in any other area. Yeah. So it is what makes you different is the emotional part, not the cognitive part. The cognitive part you cannot distinguish. Yeah, between risk averse and risk loving. You can only see higher order of beliefs. Yeah. When you look in the entry game, nothing. The two people, I mean the two different people, they have the same activity. Yeah? So basically, we can conclude there is a correlation between the insular activity, namely that it's the same for all types of people, and the behavior. The behavior also doesn't give you a difference. So that's basically what I wanted to say. I mean, I can say many more things, but then we have maybe a couple of minutes of discussion.
Thank you very much for...
Yeah, and basically, what, maybe coming back to...
We have 5 minutes for discussion.
Okay.